Okay, gentlemen, do a little review. Last week, talked about these three things you should know. This is like the most simple, basic stuff we're doing. So the first thing you're going to want to know is what is a conductor, okay? Very simple. Conductor is anything that conducts electricity. A conductor typically has 3 or less electrons in the valence shell. Now, you don't really need to know that to be an electrician, but you do need to know what a freaking conductor is. A conductor is something that conducts electricity. And then you need to know what an insulator is. Now, that's just pretty much the opposite of a conductor. It's something that does not conduct electricity. Insulators, material the insulators are made out of, they usually have 5 or more electrons in their outer shell, okay? So they're kind of stuck on there. They don't want to go anywhere. Or these, they'll pass those electrons all around and you can get them to flow, kind of like water in a hose, the electrons in a wire. Then you have a semiconductor. Okay, now what a semiconductor is a material. You know, most material is either a conductor or an insulator, but you got a handful of materials that are considered semiconductors. And they are materials with 4 electrons in the valence shell, the outer shell of that atom. Now, the reason they're a semiconductor is they can conduct electricity or they cannot. And what you do is you can add electrons to that atom and turn them into an insulator because they got 4. So insulators have 5 or more. You can take knock electrons off of it, suck them off of there. You could turn it into a conductor. So they use this electronically, like in transistors, so they can make it an insulator or conductor, and then basically it turns into a switch, which opens and closes with no moving parts, by being able to turn a semiconductor into a conductor or an insulator. But you don't need to know all of that. You don't need to know all about the electrons unless you're going to go into electronics or be a scientist. You'll be an electrician. You need to know there are conductors and insulators. And you need to know a little bit about semiconductors, but mainly these two, okay? And so this stuff was all from last week. We went over all this stuff. You guys should know that. Now, one other thing from last week, let's talk about what a circuit is. Everybody's heard, an electrical circuit. Well, what does that exactly mean? In the most simple terms, a circuit has 3 things, or needs to have 3 things, okay? Okay, I'm going to give you, this is a symbol for a battery, okay? So this will be one thing a circuit needs, all right? And then here's something else a circuit needs, right here. This will be a second thing. And then this is a symbol for a resistor. So this will be number 3, okay? So a circuit has 3 things in it, the most simple thing. The most simple circuit has to have at least these 3 things. Number 1, has to have a voltage source, okay? Number 1, it could be a battery, it could be an alternator, it could be solar panels, it could be freaking anything that makes electricity. It has to have a voltage source. Number 1, voltage source. Number 2, it has to have conductors, okay? Conductors are just wires, but you just want to say wires. A circuit could have a bus bar, or it could have little soldered areas on a printed circuit board. So it has to have conductors, but generally speaking, your conductor is just going to be wires. But we'll say conductors so we can be right without splitting hairs. And number 3, it needs to have some sort of a load. Now, this is a symbol for a resistor. That could be anything, okay? Could be a motor or anything else. So it has to have a load. So a circuit has to have 3 things: a voltage source, a conductor, and a load. If it has these 3 things, then it is considered a circuit, all right? So now, should be good with this, should be good with that. So this is so simple, let me get it out of the way. Now we're going to get in to the main stuff that an electrician will absolutely use all the time. They need to know these are the 3 main things concerning electricity that they're going to be dealing with. You're going to be dealing with voltage. Now, if you remember, voltage is a measurement. It's a measurement of how much electrical pressure there is. So you can think of it as like in a water hose. You would think of it as pounds per square inch. You know, that's how they measure it. They would call it PSI. Well, in a wire, you wouldn't call it PSI, you would call it voltage. So voltage is how much electrical pressure is built up into a wire. Number 2 is amperage. Now, amperage is it's a measurement of electrical flow or electron flow or current flow. If you can have current, but amperage will tell you how much current. You can have electron flow. Amperage will tell you how much electron flow. Again, it's like the PSI for water is for pressure. Gallons per minute, they call it a GPM. You know, you measure how much water is flowing through a pipe or a hose. In the same way, you measure how much current is flowing through a wire. But instead of gallons per minute, they call it amperage. And amperage is actually coulombs per second. Okay, so, but they call this amperage. So you can think of gallons per minute in water, amperage, or coulombs per second. Or rather than saying coulombs per second, they just call it amperage, because 1 coulomb passing by 1 point in 1 second equals 1 amp. So amperage, again, is a measurement. Number 3, the third one you're going to have to deal with is ohms. Okay, ohms, again, measurement. Measurement of resistance, all right? So ohms isn't anything in itself, it's a measurement. Again, they calculate, well, it takes 1 ohm of resistance to stop 1 amp moving at 1 volt. So they get a scale so they can measure it, and it's measured in ohms. So remember, all this stuff is really a measurement of something else. This measures electrical pressure, this measures current flow, and this measures resistance to that current flow. So these 3 things are measurements. So in a book, like an electrical book, I'll show you right now, they do this. Go back over to here. They will use something like this right here. Ooh, that is way too bright. Is the light on? There we go. I don't know where we're getting all that glare, but you see, let me turn out a light here. That more better? Oh yeah, much better. Okay, so you see they have current flow, and they have right here, they're showing it as an I, okay? And they have resistance, they're showing it as an R, and voltage as an E. But if you go clear across here, this is what they use, like if you're an electrical engineer or something. Okay, in real life, I'm going to show you that we really don't use this stuff. There's no sense transferring everything back and forth. So we're really not going to use this I, R, and E because it's the same. And I'm going to show you why in a second here, why we're not going to use an E for voltage, an R for resistance, or an I for current. Now it's good that you know that you need to, okay? That is good to have in the back of your brain so that if you run across E, I, or R, you at least understand what's going on. But in real life, current measured in amperage is an A. Resistance measured in ohms is this omega symbol. Voltage measured as electrical pressure is volts, is V for volts. So if you look at a meter, you can see, do an autofocus here. And there's a lot, yeah. In a meter, you can see that an electrical meter does not have, they have a V for voltage. They don't have an E. So I got a V here, and a V here. You can see the omega symbol here for the ohms or for resistance. They don't have an R. And you have the A down here for amperage. So, and they don't have an I. So this is a really nice fluke meter, but here's a less expensive meter. You can see they do the same thing. You have the V for the voltage, omega symbol there for the ohms. You have the A for the amps, and then you have V for voltage. We'll go over all this stuff, like what all these things mean. So back to the board. Let's take a look at this. So back on our board, we have voltage. Okay, in the book, they're going to call it E for electromotive force, okay? And they're going to call this I, and they're going to call this R for resistance. But really, in the real world, you're going to have a V for voltage, you're going to have an A for amperage, and you're going to have this omega symbol for ohms, all right? So that is what we're going to use. When we get into Ohm's law, when we do that little circle thing that you saw a minute ago, this thing right here, oops, this little circle thing with the whoop, 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 right up in here. We're not going to be using the E and the R's and all that stuff. We're going to use what's used in everyday life. Why make it more confusing? Why make it harder than it needs to be? You know what I mean? If you're going to be an electrical engineer in design, I mean, that's a different story. But this isn't electrical engineering class. This is a construction, electrical construction class. So you guys should know that V is voltage, A is amperage, the omega sign is ohms. Now, if you noticed on that meter, I'll show you right here. Go back to that meter for a second. Now you notice they got a bunch of V's on here. They got this V right here, and they got this V right here, this V right here. So these three things measure voltage. But you notice one has kind of a wave line over it, and one has a straight line with dots, and then we have 300 millivolts right there. If you look at this, there's a V with a wave, a V with a wave, Well, on this side, we have a V with a straight line. So we have all of these right here. So basically, keep this simple, we have two kinds of V's at this point. We have a V with a wave line and a V with a straight line with a dotted line over it. So you have this wavy line, it could be like this, or it could be like this. So that means there's two different kinds of voltages that you can have, all right? So here's a wave, and this equals AC. I'm sure everybody's heard of AC, which is alternating current. Now they call it current, but in this case, it's really voltage. It means your voltage is reversing polarity, like in your house, be 60 hertz, 60 times a second. But alternating current just means it alternates, goes one way, goes the other way, one way, the other way, 60 times a second for typical voltage here in the United States. And this is usually, this will be your house electricity, your plugs, your lights, industrial. I mean, I don't care if it's 480, 277, 120, 208, 240. It's all going to be this alternating current, unless it comes from a battery source. So this equals DC, which stands for direct current. So, okay, direct current is just current. It doesn't go back and forth. It's just one direction all the time. Whoop, somebody got kicked out and somebody's coming in. So battery is a battery in your car. It's just going to make direct current. Now there's an alternator in there that makes AC current here, but there's these little diodes that only lets it go one way, and it turns it into direct current to charge your battery. Probably the same way with your iPhone. That's why you can't plug your phone right into a receptacle. You need that little box, and it adjusts the voltage, so it will charge your phone, because the battery in your phone is going to be DC, and the voltage coming out of your wall is going to be AC. So it needs to switch it from AC to DC. That's why you need that little box. And that's why you can't have a cord with just a plug on it. You plug in the wall and plug in your phone. No, it needs to change it from AC to DC, because there's a battery in your phone that needs to get charged, and batteries are DC. They're not AC. Now you can take a battery and you can change that into AC if you want, but that doesn't mean that the battery is making AC, it's making DC. You have to change it. Just like your car, the old cars used to have a generator and they would make DC. The new cars have an alternator and they transform the AC into DC to charge your battery. So anyway, so when you see these on your meter, you'll know if we are talking about alternating current or direct current. So let's go back to the meters. In here, you can see there's that little wavy line. So if you were going to be measuring, right, if you wanted to measure the voltage coming out of a plug at your house, you would measure here at, AC. You can see the little VAC up here, voltage, alternating current. Now, if you wanted to measure like your car battery or flashlight battery or a 9-volt battery, there you go. We got the V with a straight line with a dotted stuff here. And there you go. You have voltage, direct current right there on the screen. So, and you can change here. This is a scale. This just tells you, like, if you wanted to, let's say you have less than 1 volt, but you know, this meter, like, let's say we put it on, well, it'll go down, looks like 3 decimal places. And let's see what this one too. So let's say you wanted to measure, you had less than 3 decimal places, you wanted to measure millivolts, you know, that's just, it's the same DC voltage right there because you're on that line, but it's going to be measuring just tiny, minute amount of voltage. So again, here we have, right here, we have the omega symbol, and that's going to measure that's a measurement of resistance, if you remember right. And see if I got the right ones. If you put it here, all these things, most of these meters will have a little thing like this right here with all these little lines that are kind of curved. You'll see this one has it right here. All this means is it makes a sound. It turns a speaker on. So when you put your leads together, if you have a reading in ohms, it will beep and make a noise. This one here, let's see if this one's louder. I don't know if you can hear this. I don't know where the speaker is, but I'll put it up here, kind of where I talk. You can probably hear that. So anyway, that's all that is. When you're measuring resistance, that little line thing here will tell you audibly, you know, with noise that you have. Now, if it's all the way open like that, you won't make a noise. I mean, you will make a noise, but if you have, yeah, there we go. We have no resistance there. If you have a lot of resistance, depending on the meter, it may not make it. It might just do a beep really quick and then give you a value. But if it's 0, that thing is just going to go, well, this is a cheaper meter. It's going to tell you that you have a complete circuit. You have continuity when it starts making that noise. Now, if you notice down here on the bottom, we have the A's. Now, we already know A stands for amperage because we talked about it on the board. But again, you have AC, you have alternating current. All right. If you look up here, alternating current. So since amperage is a measurement of current, they don't do AAC. They just do the AC. Same thing. Look, you got DC. So again, you're going to measure the amperage off a battery, like how much current flow there is, and the amperage off a like in your house, generator or something. Going to measure up there. This one has the same thing. If you look, you have your DC. Here we have milliamps DC, milliamps DC. Now, from the looks of this, looks like this meter won't measure amperage AC. I'm going to tell you the truth. Unless you're in electronics, you're really not going to be measuring amperage with one of these because it has to be measured in series with these leads. And these leads, these little wires are so tiny. Usually you have a magnetic pickup. I think I got one real quick. On AC, they got something like this. Well, you can put like around a wire. It's like a clamp. And you put it around the wire and it'll measure the magnetic field of that wire. And that'll tell you how much amperage. In this, you know, this one, I don't know what it's good for. I would assume good for 600 volts. So most of them are. It says it measures DC, I'll be. Anyway, this one's good for 400 amps. So these things here, you can see, like this one's only good for 10 amps right here. And 300 milliamps. So that's not very much, you know, in the electrical world, construction, you're usually dealing with, you know, more than 10 amps. I mean, your smaller stuff, yeah, it could be around 3 or 4 amps, but you got to figure, your breakers on your house is 15 amps, and then you load that 17%, or 20 amps at 17%. Anyway, okay, so let's get back to here. So this, you guys should know, voltage is electrical pressure. It's a measurement of electrical pressure. Amperage, a measurement of current flow. And ohms is a measurement of resistance. So this means AC, alternating current, and you can measure alternating current on the voltage like we showed, or DC voltage or AC voltage, okay? AC amperage, either way. So you can have, we're over here for your amperage, you can have these same symbols. So just remember, it depends where, if you want to set your meter, you need to know whether you're measuring for AC or DC, okay? Whether it's voltage or amperage. Resistance doesn't have any AC or DC, just plain old resistance. And so you're never going to measure resistance with a meter that has current flow in it or voltage, because it'll mess it up. You can't get a reading. You have to have no voltage and no current to measure ohms with a meter. Now you can use voltage and resistance together, voltage and amperage together, to calculate your ohms, which is Ohm's law. And you can use the amps and the ohms to calculate the voltage, or you can use the volts and the ohms to calculate the amperage. But that stuff we're going to go over, later this week. I just need to get you guys up to this point so that omega symbol means ohms, the A symbol means amperage, the voltage, the V symbol means voltage, and know that, like in your textbook, they're going to show you different ones here. But that's the only place you're going to ever see this E, electromotive force, the I and the R. The only place you're going to see those is usually in a textbook. So I wish they would get away from those and just get to the V, the A, and the omega symbol, because that's what's on your meters. You look on the back of your microwave. We've had a tag on there. It's going to tell you VA and omega symbol. I don't think it's going to tell you resistance, because actually be capacitance on that deal, but it'll use a V and an A. So it'll probably have a W for watts. We'll go into that once we get into Ohm's law. So just remember the three things every circuit needs: is a voltage source. It could be AC or DC. It needs to have a conductor, wires, solder on a printed circuit board, bus bars, doesn't matter. Has to have a load. Has to have a resistor, a motor, or something. So voltage source, conductor, or load. Every circuit needs that. Should know what AC and DC is. Voltage, amperage, and ohms. All measurements, okay? Ohms measures resistance. Amperage measures current flow. Voltage measures electrical pressure. So, and that's what I showed. That's all those meters that I had. That's all they're for, is to measure how much is going on. Because if you have too much of anything, you can burn stuff down or destroy stuff, or it just won't work. So, all right, gentlemen, that should have been a good review. Added a little bit more to it, and then we can start getting into Ohm's law. All right. Thank you very much. That should do it. All right. Peace out.